March the 11th, 2011, 2:46 p.m. For the first time, image-stabilizing cameras capture what really happens to skyscrapers when the Earth unleashes a magnitude 9 megaquake, the biggest ever recorded to hit Japan. But this is no ordinary quake. It's a megaquake that spawns a mega tsunami. Japan has some of the most sophisticated earthquake sensing technology in the world, yet experts totally failed to predict the disaster.
Nature sometimes shows its completely different, shocking face.
Now, scientists are leading a revolution to better understand earthquakes, while racing to find new ways to warn of the next one, before it delivers another devastating blow. The megaquake, a destructive force of nature that registers more than 8.5 on the Richter scale. Since the start of the 21st century, 5 of the most powerful megaquakes in history have struck around the Pacific, starting with the Indonesian island of Sumatra. And it wasn't just hit once. It was hit 3 times in 4 years. And the resulting tsunami in 2004 claimed the lives of more than 230,000 people. Chile was the target in 2010, with a magnitude 8.8. Then, the megaquake set its sights on a country all too familiar with its devastating power. Japan. March the 11th, 2011. The earthquake early warning system sounds, alerting people by siren and cell phone that something is coming. But they've heard it all before. Earthquakes are a part of life in Japan. And people are taught since kindergarten how to prepare for them. Many of Japan's buildings are designed to withstand powerful tremors. And older structures have been seismic retrofitted. But getting solid footing in a major earthquake will never be easy.
We're on the 12th floor of a 13-story building. There is very strong rolling and it's impossible to stand up. I have to hold on to something to stand, and everything's falling.
It's often a deadly mistake to think that the worst is over, especially in Japan. Previous earthquakes in this region have lasted less than a minute. The 311 Tohoku megaquake rattles on violently for 5. It peaks at magnitude 9 on the Richter scale. The shaking squeezes water from the ground in a phenomenon called liquefaction, and it spreads like a rapidly growing river. Within minutes of the earthquake ending, the tsunami warnings begin. And no amount of preparation can match the power of the coming waves. Residents closest to the coast have 15 minutes or less to get to higher ground.
ただいま15時14分です。釜石港の沖の方に大きな波のようなものが見えます。
But the city of Kamaishi has a breakwater that took 3 decades and $1.6 billion to build, so it should be protected. All bets are off when it's pummeled by a 9-meter-high wave.
港の境を越えて水が今、入り込んできています。町の方に水が入り込んできています。 ただいま、港の、境を越えて、水が、市内の方に入り込んできています。すごいです。町の方まで船が流されてます。港の境を越えて水が市内の方に入り込んできています。
In less than 10 minutes, much of Kamaishi is obliterated. And the waves aren't stopping. Traveling at 40 kilometers per hour, they flood city streets and swallow anything or anyone in their path. Unlike a tidal wave or shallow water wave caused by gravitational interactions between the sun, moon, and Earth, a tsunami is a series of waves generated by a disturbance in the ocean or small connected body of water. It comes ashore as a wave train, and it moves as a water column from the sea floor up. On 311, many evacuated. Many others didn't. Some even stood by and watched, underestimating the power of what was coming.
Yeah.
16 to 20,000 people killed by debris, drowned in the streets, or swept out to sea. Even the world's foremost tsunami experts were taken by surprise. They had no idea the water would get so high or travel so far. In the aftermath, the scope of the destruction is clear. Hardest hit was the northern coastal area of Miyagi, with more than 9,500 deaths and nearly 1,400 missing. 60% of the country's death toll. The once picturesque seaside town of Onagawa, pulverized into heaps of debris. Here, topography was to blame for the high number of casualties. As the water poured into the low-lying valley, it was trapped by the mountains, so it got deeper and deeper, making escape almost impossible. The wave reached 3 times the height than that of other areas. An American teacher documented the aftermath.
You can see all the debris that was left behind as the tsunami receded all the way up to the very top of the building.
This is where a friend of his lived until the disaster struck.
This is the approximation of where Mike's apartment was, where his girlfriend Kay was at the time of the earthquake. She got out of the apartment, went back in to get her stuff after the earthquake, and then she looked down towards the ocean and saw the tsunami coming in. And she turned and ran back towards the end of town to this hill here, where she and 15 other people running away from the tsunami scrambled up the hill, and she says that only 4 made it.
Kay was lucky to outrun the gargantuan wave. Many others weren't. Japan is no stranger to earthquakes and tsunamis, and they have the most sophisticated technology in the world. So why didn't scientists see it coming? Maybe they're facing a new kind of megaquake that creates a new kind of mega tsunami. 7 months after the 3/11 disaster, the nation's leading experts gather at a conference called Questioning the Past Seismological Research. Here they hope to figure out why the Tohoku megaquake shattered theories that they'd been working on for decades.
Earthquakes are very complex. It's like we're just building one obscure principle on top of another. We should not leave ambiguity and question everything with a critical mind. Our eyes were clouded by what you might call common sense. I painfully regret that. I feel the 3/11 earthquake has discredited everything we've done. All of our studies up to that moment became useless. I feel lost. Where should we go from here?
These Japanese scientists are world leaders in seismic research. Or at least they thought they were, until March the 11th, 2011. They devoted their energy and resources to try to identify where the next threat could be lurking. It turns out, southern Honshu was at risk of suffering a magnitude 8 or higher quake in one of 3 areas. Move to northern Honshu, and that threat doubled to 6 danger zones, all facing a possible magnitude 7 or 8 quake. But the Tohoku region looked like it would be hit first. Scientists predicted, with a 99% chance, that a 7.4 quake would strike sometime in the next 30 years. What they didn't consider was the possibility that ruptures can spread over multiple boundary zones. And that's exactly what happened. The 311 Tohoku quake rattles 6 adjacent zones, a magnitude 9 on the Richter scale, causing far more destruction than predicted. Why didn't scientists see this coming? Seismology has come a long way, but the science behind it is still pretty young. In ancient times, the Japanese believed the legend of Namazu when it came to earthquakes. A giant catfish lived under the surface of the earth and shook violently to cause great destruction. Then came the world's first seismograph, dating back to 132 AD in China. Tremors in the ground would cause a ball from inside the device to fall into the mouth of one of the copper toads, revealing the direction of a quake's epicenter. It was a first step in understanding how earthquakes work. But modern seismographs that measure earthquakes only debuted in 1880. And the plate tectonics theory that helps explain how the Earth's crust moves didn't go mainstream until the 1960s. So seismology still has a way to go. Which isn't the best news for Japan, considering that it sits right on the Ring of Fire, an area of intense seismic and volcanic activity around the Pacific, where all 5 recent megaquakes occurred. The Japan Trench lies off the coast of this country of some 127 million residents. It's where the Pacific plate subducts beneath the continental plate, like a slow-moving conveyor belt. It may look like the plates move at a pretty good pace, but in reality, they only shift about 8 centimeters a year. This movement stresses the continental plate to the extreme, causing crustal deformation and buildup of strain energy. Eventually, the stress reaches its limit, energy releases, and an earthquake occurs. Of course, things are always more complex than they first appear. The plates get stuck at what's called an asperity, shown in red. They vary in number and size, some stretching hundreds of kilometers long. It can take years, decades, even centuries for things to reach a breaking point. But when the spot comes unstuck and the plate slips, they generate earthquakes similar in magnitude to previous quakes along the same asperity. Then the 2 plates stick together again in the same spot. Asperities slip at different times and cause independent quakes. At least this was Dr. Toru Matsuzawa's model before the 311 megaquake. He and his team studied 20 years of data from seismographs, paying special attention to each quake's size, duration, and location. They identified more than 1,000 asperities, along with some of their time cycles. He thought that if he could figure out how often an asperity ruptures, he could pinpoint where and when the next quake would occur.
明日来るとか
We may not be able to alert people a few hours before or a day before. My hope is that we'd be able to estimate the threats during the coming months or at least during the coming years.
According to Dr. Matsuzawa's previous theory, the boxes are the continental plate. The conveyor belt is the sinking oceanic plate. And where the boxes touch the belt are the asperities. Shift the continental plate, and each asperity is free to slip and rupture into an earthquake. But the 311 megaquake shattered Matsuzawa's theory. He had no explanation for it, and why it was so much bigger than anyone expected. 40 seconds into the quake, the tremors weaken, similar to the Miyagi quake of 1978. That's the only similarity. Here, the 311 quake rumbles on for more than 3 minutes.
I was baffled. I had never experienced an earthquake like that before, and I honestly had no idea what had happened.
Thanks to a wealth of data, Dr. Kazuki Kaketsu can help shed light on the mystery.
This is the first time that an earthquake this big had been recorded by such a large variety of measurement devices. All of those instruments analyzing simultaneously gave us a clear picture of the earthquake.
Dr. Kaketsu reveals that the 311 quake escalated over several stages. 130 kilometers off the coast of Miyagi. 24 kilometers beneath the ocean floor at the plate boundary. The first asperity, in red, slips and causes the first wave of violent shaking. Kinkasan Island, off the coast of Miyagi, suffers one of the first blows, and a seismometer records everything. First, slight tremors. 20 seconds later, the tremors grow stronger. A temple that stood for 13 centuries starts crumbling to the ground. "40 seconds later, a second, much bigger asperity ruptures. The holy temple gives way. Then, the perfect storm. Asperities covering an area of more than 90,000 square kilometers rupture, one after another. And the quake becomes a megaquake.
The huge rupture was the deciding factor. Ruptures at asperities spread across the east side, resulting in a magnitude 9 earthquake.
In the city of Ishinomaki, drums weighing 200 kilos fly through the air. Reinforced concrete walls crumble. A seismometer on the top floor of this building records the tremors at grade 7 on the Japanese seismic intensity scale, the most severe level. But if asperities are supposed to move independently, as shown in this model, how did they rupture cascadingly to create the 311 megaquake? It all comes down to a previously undiscovered giant asperity. When it ruptures and slides, it creates a shift that affects a large area on the plate boundary and pulls neighbouring asperities along with it. It doesn't just hit one zone, it spreads over several. Dr. Matsuzawa looks back at old maps to figure out how such an enormous asperity could escape unnoticed. Turns out, 100-year-old records don't go back far enough.
There are no recorded earthquakes in this blank space. Here too. This whole area is still unknown.
The massive asperity in the blank area couldn't be detected with conventional methods of seismological study.
We think it has been stuck together for hundreds of years, and every few hundred years it releases accumulated elastic energy and slips, like it did this time. There are many other areas where asperities haven't been found. I think we need to continue looking for them.
And with good reason. Japan's seismic activity shows no sign of dying down. If anything, it's getting worse. Just 1 year after the 3/11 disaster, there have been nearly 700 aftershocks, registering magnitude 5 or higher. And some are leaving their mark.
This is really something. This is a mark left by a shift at a fault.
Since the 3/11 earthquake, this previously unknown fault line is suddenly active. A surface rupture stretches for 15 kilometers across mountains and fields. The result of a magnitude 7 quake that occurred just 1 month after the 3/11 disaster.
I'm sitting on the piece of land that plunged during the quake.
Dr. Shinji Toda thinks that the most recent inland quakes may be a result of the ground moving in a different way. Before the megaquake, the continental plate was being pushed west by the oceanic plate. Afterwards, there was a major reverse thrust and the direction switched east. The Tohoku area actually migrated east by up to 5 meters. Now, that movement is stretching the land apart, potentially creating new active faults that trigger inland earthquakes.
The ground is now being stretched, so the direction of the pressure has completely reversed. Because of this, there is a possibility that a different type of active faults have appeared.
Even hot springs are popping up out of nowhere.
I have no idea what is happening. What scares me is that the ground is sinking day by day.
Dr. Toda is also studying areas currently at high risk for devastating earthquakes. They include central Honshu, Nagano, the Kanto coastal region, and Tokyo, including its bustling metropolitan area.
It's also apparent in computer simulations that a number of earthquakes are occurring within a short period of time. Over the next several years or decades, it's highly probable that the entire Japanese archipelago will be at a heightened risk for earthquakes.
To get a step ahead of giant quakes and asperities, scientists are turning to the Global Positioning System, or GPS, which records even the slightest ground movement via satellite. Japan has a network of about 1,200 GPS stations to track the Earth's movement. The technology is similar to the navigation systems in cars. But instead of tracking vehicles, it tracks plates. When tectonic plates move smoothly together, the GPS stations detect nothing. When they stick and stress builds, the land and GPS stations get pushed in some places about 8 centimeters a year. At points where the GPS detects movement, there's a great deal of pressure on the continental plate working from the oceanic plate. Instead of subducting smoothly, the oceanic plate pushes the continental plate, causing the ground near the GPS observation points to shift. And where two plates are stuck together tightly, there's likely to be an asperity. By plotting the GPS terrain movement data, scientists can try to locate hidden asperities. Dr. Takuya Nishimura is analyzing nationwide GPS to find better ways of predicting earthquakes.
Today, we can plot the movement of the Japanese archipelago down to the millimeter.
More than 10 years ago, Dr. Nishimura found changes in the data from the Tohoku region. The red and yellow areas indicate where great pressure is exerted on the land. They cover more than 200 kilometers from north to south. So a giant asperity could exist in this area. In 2000, Dr. Nishimura published a report outlining the possibility that a Miyagi earthquake could occur at a great magnitude.
I found out that extremely large stress had been building up in a far wider area than the hypocentral regions of the past quakes. So it was my simple question, what does this mean?
But in the years that followed, the GPS data changed. Since 2007, the red and yellow areas grew smaller, and the pressure on the continental plate weakened. Nishimura assumed that the seismic threat had subsided.
I never dreamed that it could be a sign of a coming megaquake. I wonder why I never thought of it.
After the 3/11 megaquake, Nishimura compared the hypocentral region to the GPS data in his published report. On the left, the GPS data. On the right, the 3/11 quake. The two practically overlap. The giant might have been detected. And the weakening of the force on the continental plate may have indicated a coming megaquake.
I don't know whether or not precursor is the proper word. I want to take a closer look at the GPS data to see whether or not there were any kind of precursory changes.
Plotting the GPS terrain movement data can reveal locations of hidden asperities not only in Japan, but all over the world. And Dr. Hiru Kanamori points out that there have been periods of frequent megaquakes occurring on a global scale. The red marks indicate where megaquakes, those with magnitude 8.5 or higher, have occurred in the past 100 years. A cluster of major earthquakes occurred between the 1950s and 60s. But can one major quake set off a number of huge quakes worldwide?
The Earth is one continuous body, so if a major earthquake occurs somewhere in the world, it could have an impact on seismic activity worldwide.
Just like the 3/11 megaquake. It had an impact some 10,000 kilometers away from Japan. On the Mexican peninsula of Baja California, Dr. Aaron Velasco discovers that a swarm of earthquakes hit Baja in the hours and days following the 3/11 quake. One even measured a magnitude 5.2.
So that was a chain within the larger context of the surface waves of the Tohoku, which is the chain. That's the link between what happened in Japan and what happened in Baja.
The waves traveled at 3 kilometers per second and were recorded all over the world. Everywhere they passed, China, Russia, the United States, Mexico, earthquakes occurred. Scientists now believe that the United States is in danger of a major quake, with devastation so widespread it could reach. A research team at Oregon State University is also using GPS to observe ground movements and to see if there's any sign of a huge quake on the horizon. About 300 years ago, a magnitude 9 earthquake hit the west coast, spawning a giant tsunami that spread across the entire Pacific Ocean. It reached Japan about half a day later, striking areas all along the coast with a 5-meter-high wave.
We've seen the devastation that these events can cause, so we have to be ready all the time. It may occur tomorrow, it may not occur for hundreds of years.
Dr. Nishimura is getting closer to figuring out that answer. Data from the GPS stations has helped him identify some areas in Japan that could be targets for the next megaquake. One is the Nankai Trough, stretching southwest off the coast of Honshu. If stress continues to build from Tokai to Kyushu, Nishimura fears that cascading ruptures could occur and result in a magnitude 9 earthquake. He also finds pressure building off Japan's northernmost island of Hokkaido, in an area equivalent to the size of the giant Hesperity off Tohoku.
In terms of scale, the Nankai Trough and Hokkaido are both accumulating great enough stress to cause a magnitude 9 class megaquake. The risk for a major earthquake is increasing.
And Tokyo, Japan's capital, could be next. In 1923, the 7.9 magnitude Great Kanto quake devastated Tokyo, killing more than 100,000 people and burning the city. Today, an Hesperity lies on the exact same fault. If an earthquake were to happen, violent tremors would spread throughout the Kanto region, and a huge tsunami the coastal areas. This devastation would wreak havoc on Tokyo's urban center.
GPS technology has only begun advancing over the past decade. So we shouldn't rely on it too much, or shouldn't say, for example, that this area is safe because there is no accumulation of strain. In this day and age, we can't just use current methods to judge where the threat lies. We need to look at more possibilities.
But figuring out this megaquake and where the next one may strike is only half the battle. Megaquakes are known to create mega tsunamis. And the one that hits the coast of the Tohoku region on 3/11 is far more deadly and destructive than the quake itself. Scientists underestimated them both. So now they need to solve the mystery of the monster wave. In the coastal city of Miyako, most of the district was turned to rubble, despite the fact that a 10-meter-high seawall was built to protect it. But no one, including Dr. Fumihiko Imamura, imagined that a tsunami could be big enough to breach the seawalls.
It's dumbfounding, like a bad dream, a nightmare. It's hard to believe it's a reality. It was as if everything was denied. Everything I had done up until now was for nothing. I had no idea what to do going forward.
Still, he presses on, searching for clues and answers. Just like the 3/11 megaquake that triggered it, something about this mega tsunami is different than any other. What he finds is a surprising new pattern of sea floor movements. March the 11th, 2011. On the plate boundary off the coast of Miyagi, the area highlighted in red shifts and generates an earthquake. Seafloor pushes up, creating a large tsunami. Then a second shift is triggered, highlighted in yellow, and inconceivable prior to the 3/11 disaster. The seafloor shifts as much as 50 meters and creates a second tsunami. The two waves combine and become one monstrous force. The initial tsunami is 2 meters high. Then it's pushed up by the second tsunami, growing to more than double its original height. Bigger than experts ever thought possible. The wave pummels the shores of Japan at wildly different heights. Some places up to 39 meters. And it doesn't stop there. Imamura theorizes that a third tsunami was created when plates shifted off the coast of Fukushima, where the Fukushima Daiichi nuclear power station is located. Here, the waves hit. Water crashed over the breakwater. Water levels rose, and the breakwater was completely submerged. Waves even splashed above a 44-meter-high reactor building and intensified as they piled on top of one another. The reactor buildings flooded, power shut off, and a nuclear crisis was unleashed when backup generators failed. Workers rushed to vent steam to relieve the pressure caused by intense heat. But they were too late. The hydrogen buildup caused an explosion, destroying buildings and equipment. It was a full-scale meltdown, the worst nuclear accident since Chernobyl. The scale of the destruction and the disaster itself weren't accounted for in the minds of the scientists. And even though the mystery of the mega tsunami is starting to unravel, there is still much left to solve before the next megaquake hits. Imamura's theory can't explain all the events, because the tsunami hit in unexpected areas.
It was easy to understand why there were large waves near the epicenters around Miyagi Prefecture and in the Sanriko region. We also had clear evidence of very big tsunamis hitting north of Miyako. But these couldn't be explained by existing earthquake or fault models.
It's a question that someday he hopes to answer.
It's possible that off the coast of Miyako, an unusual type of tsunami occurred. There are various models, such as the chained quake sequential model, but I believe we'll have to review all and come up with new models.
It's just a matter of time before the next megaquake launches the next mega tsunami. The one that hit on 3/11 was enormous. Is it possible that an even bigger one is on the way? Dr. Makoto Okamura turns to the past for clues to future tsunamis. He and his team examine samples from Tosa City in Kochi Prefecture and discover that a mega tsunami hit the area 2,000 years ago. The sediment carried inland was more than 60 centimeters deep, 3 times deeper than the 3/11 waves.
Even the greatest depth of sediment deposited by the 3/11 mega tsunami was only about 20 centimeters. So compared to that, this depth is extremely huge. We think the tsunami was so huge that it scraped up the sea floor. It came in once, twice, and then a third time. And each time the waves were quite large.
It could be a sign of ominous things to come. But will Japan ever truly be prepared for this kind of disaster?
We've seen that it happened 2,000 years ago, so when it happens again, we can't escape responsibility by saying we didn't expect it. I think that's quite critical.
To help calculate the risk, Professor Yoshiaki Kawata sifts through patterns of tsunami generation, searching for worst-case scenarios.
We mustn't say it was unexpected again. We have to learn from the Great East Japan earthquake and make thorough calculations to find out what will happen next, using any available data now as much as possible.
Kawata believes that a massive tsunami could occur in the Nankai Trough off the coast of Shikoku, the same way as the 3/11 megatsunami. Scientists previously thought that only the red area in the continental plate moved to cause a tsunami. If the yellow area shifts with the red, the end result could be a megatsunami. Osaka, one of Japan's largest cities, could suffer severe damage with 6-meter-high waves. The water would tear through the city, over embankments, and flood the streets. Dotonbori district would be engulfed, as well as the neighboring districts of Yodoyabashi and Umeda. And that's just with one wave. Inland areas would also be inundated, as well as Osaka Castle, 10 kilometers from the coast. But what happens if there's more than one tsunami? Like what happened on 3/11. Kawata has done countless calculations to estimate the largest possible tsunami. But his work is far from over.
When you consider typhoons, in the past 50 years, no two have been the same in size and path. Earthquakes and tsunamis are also very diverse. We must calculate 100 million cases to see what height waves can reach.
If 2 tsunamis hit Kochi City with a time delay of little more than an hour, monster waves up to 18 meters high would create a mega tsunami. But first, a quake's violent shaking would cause the city to crumble. Roads would be blocked, preventing the evacuation of people. Then, the waves would come. Double the height of the previous estimation. Once again, scientists turn to the past to understand what may come in the future. Japan's efforts at a tsunami warning system date back centuries. On the shores of Sendai City, scientists unearthed traces of the Jogan tsunami that struck in 869. They confirmed it was a mega tsunami that engulfed the entire Tohoku Pacific coast. The Namiwaki Shrine has been standing since the legendary Keijo tsunami of 1611. Its name means dividing waves, a stark reminder to future generations that a tsunami once reached this point. The waves of the 311 mega tsunami also came close. In a famous waka Japanese poem, it's said that waves never roll over Tsuno Matsuyama. A stone monument stands before two old pine trees, and the epitaph reads, "A pine hill at the furthest reach of the waves." This may have been a warning left by ancient people, or a sign of what may come.
I believe we need to look once more at exactly what message our ancestors left and what scale of disasters they warned.
But even back then, it may not have been a massive earthquake that created a mega tsunami. Since the 311 disaster, surveys of the seafloor have been conducted off the coast of Tohoku. It turns out, seabed landslides can also be a culprit. It's a phenomenon where a quake at the plate boundary causes an ocean floor slope to collapse. Vast amounts of sediment break off from a slope, displacing water and pushing it up to generate a large tsunami. To determine just how big it can get, researchers turn their attention to Ishigaki Island to investigate a tsunami that struck here in 1771. The Meiwa Mega Tsunami. An earthquake hits at magnitude 7.4. Then a huge tsunami. A big black cloud 30 meters high rips through entire villages, killing 12,000 people and destroying everything in sight. But no traces of a tsunami this size exist on other nearby islands. Dr. Kazuhisa Goto is here to figure out if this mega tsunami was the result of a seabed landslide. The wave was powerful enough to carry a 220-ton piece of coral 500 meters onto shore. So why did it only strike Ishigaki Island? If a megaquake hit the plate boundary south of the island, a tsunami would strike other neighboring islands. But if a smaller scale quake hit and caused a seabed landslide, only Ishigaki Island is struck.
In this area, the tsunami is 30 meters high. At the same time, waves aren't so high on Tarama Island and Miyako Island. It's hard to anticipate when seabed landslides will occur. In addition, even a small earthquake can cause a seabed landslide, so there will always be a possibility that large tsunamis will occur. That kind of danger is to be reckoned with.
Today, the danger looms over Tokyo. Not the threat of a seabed landslide, but a megaquake that sparks a mega tsunami. Until recently, huge tsunamis weren't expected to hit this area. Dr. Tomoya Shibayama is trying to find out what will happen if one strikes that exceeds previous estimates.
We should review the current safety plans on the assumption that a large tsunami could strike anywhere in Japan.
If that happens, experts predict that it would likely hit the city of Yokohama first. A commuting hub with little tsunami protection. Parts of Yokohama sit less than 3 meters above sea level. So water would pour into the heart of the city, bringing transportation to a halt and trapping hapless victims underground. Then, the wave would travel farther into the bay, damaging chemical plants, causing hazardous material leaks and igniting fires. The tsunami enters farther into Tokyo Bay. On the shore of the innermost section of the bay stretches a low-lying land close to sea level. Embankments weakened by the quake might collapse. And people in low-lying areas could be stranded for days. Even a major metropolis can be defenseless against the raging waves of a tsunami. Shibayama hopes for revised plans to ensure safe evacuation from future tsunamis. But one seismologist warns that there may not be much time left. Professor Kerry See from Singapore.
We don't know about the Ryukyus. Could we have a giant earthquake produced by the megathrust there? That you're expecting a large event here in the Tokai Gap and along the Nankai Trough. One question you have now in Japan is, could this generate a great earthquake?
Dr. See and his team have spent the last decade studying chained earthquakes in Indonesia using fossilized coral. Coral only grows underwater, so when the seafloor rises during a quake, the top is exposed to air and dies. The coral below the surface keeps growing. Since the cycle continues with each earthquake, scientists can determine when megaquakes have struck in the past. See discovered that this region has experienced series of magnitude 8 class megaquakes about every 200 years. Since the quake of 1833, nearly 200 years passed without one.
This is 1660. We went up a meter or so. Recolonized to 1797 and then up.
Yeah.
Then, in 2004, a magnitude 9.1 earthquake shakes the Sumatran coast and causes a mega tsunami. Another quake strikes in 2005 at magnitude 8.7. Based on his research, See estimated that another one would occur farther south. Then, in 2007, just as he warned, a magnitude 8.4 earthquake rocks a plate boundary zone in the south. Now, C predicts the same situation may exist in Japan.
A big earthquake may not mean the end. It may mean the beginning of the failure sequence. They're going to have to live with some degree of ambiguity and some sense of fear that something big could happen again.
But big things have already been happening with mega tsunamis since the start of the 21st century. Scientists at Hawaii's Pacific Tsunami Warning Center share information with 39 countries 24 hours a day.
Near coastal northern Chile, 4.4 magnitude. Off east coast of Honshu, Japan, 4.8 magnitude.
They also monitor more than 50 seafloor tsunami sensors positioned around the world.
A big tsunami, it will travel across the Pacific. It will set the entire ocean oscillating. It will have an ocean-wide reach. It will affect all shorelines.
Just as it did on 3/11, less than 8 hours after the megaquake in Japan, a 2-meter-tall wave hits Hawaii.
Pouring over the water, you can see I'm completely stranded now.
In Chile, a 2.5-meter wave washes in, more than 17,000 kilometers away from Japan. And a thick ice sheet collapses in Antarctica, carving icebergs the size of Manhattan. The power of nature can leave even the best scientists feeling powerless.
Unfortunately, the disaster is not over. The threat will continue further on.
And it has. Since January 2012, more than 20 magnitude 5 quakes have struck the Kanto region. Dr. Naoshi Hirata and his team positioned seismographs throughout the region and determined that since the 3/11 megaquake, there have been thousands of quakes. Hundreds have registered magnitude 3, shown in red. That's the level that shaking can be felt. When plotted on a 3D model, the hypercenters seem to line up along 2 planes at different depths. These are the plate boundary planes. In fact, the ground underneath the Kanto region contains 3 extremely complex tectonic plates. The lowest is the Pacific plate, subducting from an easterly direction. Above it is the Philippine Sea plate, subducting from a southerly direction. And on top is the Eurasian plate. Hirata believes that frequent earthquakes on these plate boundaries are caused by changes in crustal force working in the Eurasian plate. The Eurasian plate is being dragged to the east. Stress is building on the plate boundary with the Philippine plate, which is also being dragged east, and stressing the Pacific plate boundary. Combine these forces, and the result is a large number of earthquakes.
Along the plate boundaries, stress is building up quickly. That's the situation I think we're in. The balance of the forces which operate at the plate boundaries has changed a great deal since the March 11 event.
Hirata warns that the threat of a major earthquake is high in the Kanto region. and that it may happen on the shallower plain between the Eurasian and Philippine plates. Quakes from a shallow depth cause more intense shaking than those from a deeper area. He also identifies parts of the Kanto region near Tokyo where stress is accumulating and where powerful quakes have hit in the past, including one in 1855, estimated to be greater than magnitude 7 and killing 7,000 people.
Looking at the situation following the 3/11 megaquake, magnitude 7 earthquakes can happen at any time. I believe we need to prepare for a powerful earthquake as soon as possible.
The clock is ticking for Tokyo, with an estimated 70% risk for a magnitude 7 quake sometime in the next 30 years. Major stress is already occurring at fault lines directly beneath the city. And the Japanese government announced which ones may have grown more dangerous since the 3/11 megaquake. Dr. Hiroshi Sato investigates the Tachikawa fault zone.
As you can see, the tea plantation in front of us is slightly sloped. The fault is under it.
Dr. Sato believes that part of the blame can be placed on movement of the Eurasian plate after the 3/11 megaquake. The Tachikawa fault zone beneath this region had been tightly sealed by pressure to the west. Now the plate is being pulled east, decreasing the pressure and increasing the chance that the fault will slip.
Now the fault can move easily. So I think the Tachikawa fault zone is one of the faults we will need to keep an eye on.
But there are 3 other faults that could cause huge earthquakes.
We've experienced an extremely big shift in the Earth's crust, so the level of danger may definitely have risen.
This is one of the faults that worries Sato the most. It may be longer than suspected. If it is, it could generate a huge quake directly under 2 of Tokyo's most populated areas.
I think that finding out whether there is a fault here is one of the major issues that needs to be checked out.
If Tokyo is struck by a major quake, the ultimate nightmare would play out. More than 100,000 buildings would collapse. As many as 200,000 structures in residential districts would burn down by the afterfire. Liquefaction would keep fire trucks from reaching the hardest hit areas. Government officials estimate that the city of Tokyo alone would suffer nearly 10,000 fatalities. Then, a sleeping giant may awaken. Mount Fuji, that sits just over 100 kilometers from Tokyo. For the past few years, more than 50 small quakes have rumbled deep in the earth around Mount Fuji. And it's thought that a magma chamber exists about 15 kilometers below the mountain. Mount Fuji was quiet for about 300 years, until it attracted scientists' attention in March 2011. Just 4 days after the 3/11 megaquake, a magnitude 6.4 quake rattles Shizuoka, about 15 kilometers below ground and located beneath Mount Fuji. According to Dr. Toshitsugu Fuji, quakes occurring beneath volcanoes can lead to full-blown eruptions.
The earthquake occurred right under Mount Fuji, so we were concerned that an eruption might take place. We paid close attention because an earthquake occurring directly beneath a volcano can trigger an eruption.
And that's exactly what happened in other parts of the world. After the 2004 megaquake in Indonesia, one volcano after another erupted. Since then, volcanoes have erupted in places like Sumatra and Java. Experts are focusing on whether that megaquake had an effect on these volcanoes. Over the last 100 years, 5 magnitude 9 megaquakes have hit worldwide. And so far, all but Japan's have one thing in common: a resulting volcanic blast.
When magnitude 9 earthquakes occur, they bring with them volcanic eruptions. All of them were followed by eruptions immediately or within a few years. There have been no exceptions so far.
This is a detailed topography map of Mount Fuji's surface. Volcanic craters are at the summit and all over the surface of the mountain, which suggests that eruptions have occurred in many different places. The largest is the Hoei crater, created during Mount Fuji's last eruption in 1707. Just 49 days after the estimated magnitude 8.7 Hoei earthquake. Since the 311 megaquake, scientists have seen changes in the pressure of the magma chamber below Mount Fuji.
Just because it's quiet right now doesn't mean that we can rest in the assumption that it will remain calm forever. I think we have entered a stage where Mount Fuji could erupt at any time.
But why do eruptions occur after a megaquake? Nearly a year and a half after the one that hit Chile in 2010, a volcano in the Andes Mountains spews the largest eruption in 50 years. An ash plume shoots 14 kilometers into the atmosphere. Ash and pumice stones spread over a wide area of South America.
Black smoke blew in and the sky turned completely dark. Lots of stones and ash rained down. The sound of thunder was so loud I was terrified.
The oceanic plate off the coast of Chile moves east under the continental plate. Temperatures over 1,000 degrees Celsius melt rocks within the plate and form magma up to 100 kilometers underground. The magma rises until pressure from surrounding bedrock stops it. For the first time, the sudden rise and eruption of volcanic magma following a megaquake could be studied. Dr. Fernando Gil believes that large shifts in the ground resulting from the megaquake caused the volcanic eruptions in Chile.
Before, the force was pushing it this way, but after the earthquake, it changed into a force pulling the mountains in the opposite direction. This allowed the magma to rise.
Gil believes that this ground-stretching force also occurred underground, weakening the force of the bedrock holding down the magma and resulting in an eruption. In this model of his theory, the gelatin represents bedrock and the red oil magma. Before an earthquake, magma rises until surrounding bedrock prevents it from going any further. But when the bedrock is stretched or loosened by a megaquake, the magma starts to rise, and eventually it bursts out onto the surface.
Because of the pulling force, a route was created for the magma. That made it easier for it to rise up to the surface.
The same thing could be happening beneath Mount Fuji. But scientists are seeing major changes in many of Japan's volcanoes, especially in the central and northeast regions, where the 3/11 megaquake caused the most damage. On Mount Akita Komagatake, the temperature around the summit is rising, and areas of high geothermal heat, shown in red and yellow, cover a much larger area. And new fumarolic gas vents have been discovered on Mount Azuma in Fukushima. Since the 3/11 megaquake, it's now believed that the force stretching the landmass may also be having an effect underground. Dr. Eisuke Fujita analyzes ongoing data from the 3/11 megaquake. A scale from red to blue indicates how much the underground bedrock is being stretched. Red represents a strong force. The ground beneath Mount Fuji is light red. Compared to the data from the eruption in Chile, Mount Fuji has roughly the same degree of stretching. It's already vulnerable. Fujita analyzed what changes would happen if there was magma, represented in light blue, 15 kilometers below Mount Fuji. His calculations show that stretching forces may be working on the magma chamber.
If the magma is in a very unstable state, where it can erupt with just one push, and if the forces acting on the magma weaken even just a little, then the magma can rise easily. I believe it is necessary to acknowledge the possibility of eruption in the near future.
If that happens, there are two worst-case scenarios. First, a major eruption halfway up the mountain with lava flow, like the one that occurred nearly 1,200 years ago. The lava moves slowly, burning everything in its path. After a week, it'll reach Fuji City, forcing more than 250,000 people to evacuate. Transportation linking East and West Japan will be severed, and it will take years for the city to recover. But there's a much more sinister scenario to consider. Mount Fuji could unleash huge amounts of volcanic smoke and ash, just like it did in 1707. Then, rapid air movement or an atmospheric shock wave would shatter windows. Wind would carry the ash over long distances. And because it has an electrical charge, there could be widespread power outages. Eventually, it would reach Tokyo, burying parts in more than 10 centimeters of ash. It sounds like a small amount, but it can equal the weight of a few tons. Houses would collapse under the pressure. Roads would close. Airports would shut down. Trains would come to a screeching halt. The city would be paralyzed. Megaquakes, mega tsunamis, volcanoes. There are some bleak forecasts on the horizon for Japan. But there are also breakthroughs for scientists trying to better detect these events. For the first time, experts have discovered not one, but two possible precursors to a megaquake. Deep in the ocean off the coast of Japan, a team is gathering data from ocean bottom pressure gauges. Machines that record movements of the seafloor. One of these gauges was in place during the 3/11 megaquake. It turns out the seafloor rose nearly 3 meters that day, typical for such a large earthquake. But another transformation had already started 2 days earlier. A tiny shift before the big one. A 7.3 magnitude quake on March the 9th shifts the seafloor up 10 centimeters, then continues to elevate. Dr. Ryota Hino believes this indicated an even bigger event was on the horizon.
I believe that our observation equipment captured a part of the process which culminated in the March 11 megaquake.
Hino theorizes that the March 9th quake pushes the gauge in red up slightly. The plates continue to move for 2 days at the ruptured part. Then, on March the 11th, several asperities rupture, causing a 3-meter seafloor elevation and megaquake. If scientists can catch subtle indications like these, they could issue warnings and potentially save thousands of lives.
I believe that this study is significant as it may enable further understanding of earthquake processes and hints to earthquake prediction.
But early earthquake detection doesn't only come from far below. It also comes from far above, in outer space. The ionosphere is the last layer of atmosphere between Earth and space, where auroras appear. Dr. Katsumi Hattori studies the ionosphere using data captured by satellites. In the days leading up to the 3/11 disaster, something totally unusual happened. Normally, radiation from the sun's rays acts on molecules in the ionosphere, shown in blue, to produce electrons, in yellow. There are many more electrons during the day than at night. The same is seen over Japan. The red and yellow areas are the high levels of electrons during the day. At night, there aren't as many, so the colors disappear. But 3 days before the megaquake, an irregular pattern appeared. The colored areas remained, even at night.
Normally, the condition of the ionosphere never remains the same. It changes along with the Earth's rotation. This particular condition was a very rare case.
Scientist Dimitar Ozanov analyzed heat patterns above the Tohoku region during the days leading up to the 311 disaster and discovered an irregular change in the atmosphere. On March the 8th, a heat ring appeared, shown in blue, and peaked the day before the megaquake. The energy levels were similar to a typhoon.
What is interesting, that the entire area is elevated with the thermal radiation. We see anomaly over the Japanese fault system, which means that it's a major disruption and major release of gas in the atmosphere.
Ozanov believes the same tectonic plate movement that caused the earthquake may have also affected the ionosphere. Before the quake, rocks within the tectonic plates fractured and released gases like radon, which changed the atmospheric heat. He found similar anomalies before major earthquakes in China and Turkey. Because this potential earthquake detection relies on satellite technology, scientists could use it to detect quakes before they occur anywhere in the world. Key for countries often hit the hardest.
1 year after the Tohoku earthquake, we still have lots of unanswered questions. But what we have found so far, and we know that we have found pre-earthquake signals reliable enough to continue to be studied in Japan. So we getting involved much more scientists from Japan to do that, and I'm very optimistic.
So is the team of researchers studying the sea floor. Today, more gauges and seismometers are being installed for long-term monitoring of seismic activity in the area.
We are reaching a point where people in all sorts of professions must use whatever means available to reduce the damage caused by such disasters. As a seismologist or just as a resident in Japan, I feel really sad as many bad things happened. It is simply too painful. However, I believe that it's our responsibility to learn as much as possible from the experience.
Scientists have made great strides in the understanding of megaquakes and megatsunamis. But in reality, there is no such thing as earthquake prediction. Only estimations can be made. But the hope is that early detection will lead to quicker, more accurate warnings, which ultimately could save thousands of lives.
I hope I can warn people, not just in Tohoku, but in all of Japan, more clearly before a megaquake event, and let them have time to make a certain measure of preparations. Seismology has come a long way and advanced much. I'd like to continue my research with a belief that these years of efforts will make the future better than the present.
Seismology has evolved over the years, but so have the earthquakes.
We usually get the full picture of a past quake in about 1 year, but it could take decades to fully understand the 311 earthquake. Even if it takes time, I think it is our duty to find out what happened and what will happen next. I plan to work diligently to unravel the mystery.
The Earth is already moving toward the next megaquake. Only time will tell where and when it will unleash its power.